All right, so here is our quiz review, and notice it says here at the top, number 4, change to side C. So number 4 right here should say side C. All right. It says in numbers 1 and 2, refer to the triangle at the right. Find the exact value of the tangent of angle C. Well, first of all, I want you to notice that this is a right triangle. Because this is a right triangle, we can use right triangle trig. We can use sine, which is so, cosine, and tangent. We do not need to use law of sines or cosines. We only use law of sines or cosines if it's not a right triangle. So the tangent of C is opposite over adjacent. I'll write it all out. Right, and this is in reference to angle C, which is right here. There's angle C. Opposite of angle C, and I always like to label my hypotenuse. Opposite of angle C is 5. And adjacent to angle C is 10. So I get 1/2. I don't need to use law of sines or cosines. I can simply just do tangent, opposite over adjacent. 5 is opposite, 10 is adjacent. And number 2 says find the measure of angle B to the nearest tenth of a degree. Angle B, so for this one, I'm looking at angle B, which is right here. So what I need to decide is, I know I'm going to have to use an inverse. I can either do inverse sine, inverse cosine, or inverse tangent. I have to decide which one to do. Inverse sine would be 10 over 5 square root of 5. Opposite over hypotenuse. Inverse cosine would be 5 over 5 square root of 5. Adjacent over hypotenuse. Inverse tangent would be opposite over adjacent. Well, if I had to pick which one of these to put into the calculator, and I can use a calculator, I'm going to use this last one. And I'm simply going to type into my calculator, because I'm choosing this one, inverse tangent of 2. And I'll get an answer. I'm going to make sure my calculator is in degrees. And it is inverse tangent of 2. And I get, it says to the nearest tenth, 63.4 degrees. And that's all I have to do. That's it. I don't need to use law of sines or law of cosines. Number 3. A ladder is positioned 12 feet from the base of a building. Okay, here's my building. There's my ladder. So this is my ladder right here. And it's 12 feet from the base of the building. So this is my 12 feet. This is my right angle. And I have a right angle, so I'm going to use sine, cosine, and tangent. I'm not going to use law of sines or cosines. The angle of elevation from the base of the ladder to the top of the building is 68 degrees. So right here is my 68 degrees. Find the height of the building to the nearest foot. So this is what I'm looking for right here. This is my x. So I need to determine what's the relationship between the pieces of information I know and the one piece of information I don't know. This is my hypotenuse. So my angle, I have opposite and adjacent. I am not involving the hypotenuse at all, so I don't want to use sine or cosine. So I'm going to use tangent because these three have a tangent relationship. So tangent of 68 degrees equals opposite, which is x, over adjacent, which is 12. And I cross multiply. X equals 12 times the tangent of 68 degrees. Go to my calculator. 12 times the tangent of 68, 29.7. It says to the nearest foot though, so that would be 30 feet. This 29.7 would round to the whole number 30. Okay. All right, my next question, number 4. In a triangle ABC, little a is 4.8. Remember, little a is always across from capital A. Little b, 7.5. And angle C is 42 degrees. Whenever I have side, angle, side, this is when I want to use law of cosines. So I'm looking for side C. This is the side I'm looking for. So this is the angle on the side across from it that I highlight. So this is the side I don't know. C squared equals 4.8 squared plus 7.5 squared minus 2 times 4.8 times 7.5 times the cosine of 42 degrees. Because my variable's here and there's no variable here, I can put this whole piece into my calculator. And I get 25.78357,257. And I'm going to take the square root. I don't need plus or minus because C has to be positive because it's the length of a side of a triangle. So I take the square root of 25.7. And I get, does it say what to round to? It doesn't, but all of those are rounded to the nearest tenth. So I'll round to the nearest tenth, and I get 5.1. Okay. Number 5, in a triangle, ABC. Side A is 6.4. Side C is 8. And angle C is 38 degrees. So for this one, since I don't have side angle side or side side side, I'm going to use law of sines. I have this information, and let's see, I'm looking for angle A, so I'm looking for this one here. So I can use law of sines. Sine 38 degrees divided by the side that corresponds to it equals the sine of A divided by the side that corresponds to it. Going to cross multiply. 8 times the sine of A equals 6.4 times the sine of 38 degrees. Trying to solve for A, I've got to get rid of that 8. So I'm going to divide those sides by 8. Sine of A equals all of this here. Let's see what that equals. 6.4 times the sine of 38 divided by 8. And I get 4925 291803. I'm looking for the angle, so I need to take the inverse. Anytime I'm looking for an angle, I'm going to have to use an inverse to get it. And A equals the inverse sine of all of this. So in my calculator, I put inverse sine of 4 and I get 29.5 degrees, and it's set to the nearest tenth, so I'm done. All right, now, number 6, find the area of the triangle. This is where I have to use my formula. Area equals 1/2. 2 of the sides, I'll call them A and B, and therefore the sine of C. So it's when you have side angle side. So I'm going to use, this is the angle. I don't want to use side C. I want to use A and B. So these are the 2 I want to use. This is where I have that corner. So area equals 1/2 or 0.5 times 8 times 6 times the sine of 40 degrees. And I get 5 times 8 times 6 times sine of 40. And I get 15.4. Didn't say what to round to, I'll just go 15.4 centimeters. And that'll be squared, because area is square centimeters. All right, let's go to our next page. A couple extra problems to do. 3 lifeguards are positioned as shown in the diagram below. They would like a buoyant line that would run from stand 1 to stand 3. How long would the line have to be? Notice again, I have side angle side. Whenever I have side angle side, I use law of cosines. Here's this angle on the side across from it that I'm looking for. I'll call this x. So I would do x squared, and we're going to work here, equals 97 squared plus 105 squared minus 2 times 97 times 105 times the cosine of 130 degrees. You put all of that into the calculator and you get an answer, and then you take the square root of both sides and you'll get an answer for x. Really want you to try and work through that one on your own. All right, and then the last problem here, we have triangle POS. Angle P is 17 degrees, angle O is 107 degrees, and P to O is 7. So I have this, which means, I might be able to use law of sines, find the lengths of the other 2 sides. Well, I'm going to start off looking for this one here. So I'm going to use law of sines and say sine of 107 divided by 7 equals sine of 17 divided by x. I cross multiply. 7 times the sine of 17 equals x times the sine of 107. Solving for x, I divide by the sine of 107. And I'm going to put this into my calculator as 7 times the sine of 17 divided by the sine of 107. And I get 2.14 2.5